Now, moving on from something like Google Spreadsheets, this will seem a lot more difficult and a big step up, but it has huge benefits by the fact that it can deal with masses and masses amounts of data. It is transparent, and you can control the flow of the data manipulations a lot more. So in this sense, I would like to introduce you to R. It is a data manipulation and statistics package. It is free to download. It is open source and it is maintained by an academic community. So it's very powerful in the data analysis and statistical analysis with which you can use on very, very large data sets. It also has very good visual libraries that aren't necessarily the most pretty or newspaper ready, but they can glean a lot very, very quickly. So if you've downloaded the data, saved it to your desktop as a CSV, download R. And to open it up, we need to set the directory to what R is looking at. So getwd will tell you the directory that's looking at. And now I want to set that to the desktop. So let me do that now. Now I can go and point it to the CSV that's sitting on my desktop. And that is this line here. I'm also giving it, the CSV, the dataset that's reading it, a name so that I can refer to it. And now I can write this directly in the console, but this is an editor where I can write all my code, and then to run each line, I can either highlight it and hit Command Enter for Mac. I think it's Control Enter for PC. Or I can just put my cursor on the line and hit Command Enter. So this should be reading in this original data set. And I can take a look at the headings. This will give me all the headings. So if you've got a massive, massive data set, you can explore bits of it this way. You can get the first 10 rows, in case it's very, very big. And if it's blank, it will fill in NA, which is very, very important statistically, because you can't get a mean or a median or sum up anything that where value is not there. It will not know how to handle it. So we have to handle it in specific ways. So that is reading it in. The next thing I need to do is to convert decision date to an actual proper date format. Now I know this is put in the format of this is day, this is month, day, and then year, and year has 4 digits in it. So to refer to a specific column in the dataset, I've given the dataset the name Somali Aid. To refer to any of its columns, I use Somali Aid $, and then the name of that particular column. So I am using the asDate function to say I want to format the decision date as a date and putting it in a new column called date. And I can just refer to it by saying Somali Aid $date. And this is the format that I know it's in. I know it's in month, which is in digits, day, which is in digits, and year, which is in 4 digits. So year gets a capital Y. A small y would mean 9811. So I can reformat that. And to make sure it's gone in, I can look at the names again. And date has come in. And then I can take a look at the first ones there. And I can see date is coming in as a date format. Now, what I need to do to recast it is to deal with this structure here. The fact that the categorization of the particular donors is done by columns with a long list of the different types of donors that there could be, the different categories, and a one for which category that fits into. Now, this is not good for data manipulation, but for data visualization, they have to handle new lines on a graph by actually specific columns. So we're going to reform that into a single column with categories and then recast that again. using the pivot table. Now this is something which Excel and Google spreadsheets cannot handle. And sadly enough, this is the sort of thing that a lot of structures, data structures that aren't clean, they do things like this. But we can handle it if we know pieces of code that will go and fetch things. So this is a for loop, which is going down every single row and only looking at columns 6 to 16. So unlike most programming languages, or all programming languages, R starts counting at 1 rather than 0. So this is column 1, 2, 3, 4, 5, 6. So this little loop is iterating through all this area here, going down all the rows and looking at only the categories. And this if statement is saying if the entry that is in that particular row and column in each, so it's looking in each of these squares, and it's saying if it's not nothing, if there's something in there, if it's not blank, because don't forget when we read it into R, it's filling blanks with NAs. It's saying if it's not blank, such as this one here, add a new column called category, add it in for that particular row, in there, give me the name of that column. So if we run this, I can show you what it does. And so if we go into the names again, there's a new column called category. And we'll take a look at the first 6. And you'll see here that it's gone and it's fetched. It's made a new column called category and it's gone and put in the category that actually was in column form across columns into one specific column. Now I'm going to need this column to pivot the data in terms of date and category. So to do a pivot table in R, we use the function aggregate. And I'm giving it a new name just so that I can take a look at it and then manipulate that. In that sense, I'm not manipulating the original. It's not changing, I'm not overwriting anything. So I'm aggregating the sum, which is at the end here, of the US dollars committed / contributed by the category, which I've made, and by the date, which I've made. So if I do that, you'll see what format it's now in. So if I call category donations by day, you can see here, it's now recasted by each category for each day and given me the sum of the donations. Now, if I want to put this into a visualization where for each day I have a different line for each category of the donations they've made, I then have to reform the structure so that category is not one column, so that each of these are individual columns. To do this, I use a library in R called reshape. Now, this is the good thing about open source and about R, in that people will make packages that will handle things so that you're not dependent on, you're not restricted to using tools, you can write them yourselves, or mostly other people will write them for you. And you just need to call them, and you have it written in so you know exactly what it's doing, and you could take a look at each stage of what it is doing. So I'm going to show you what this is doing. So I'm casting the category donations by day, the thing we have here. I am casting that by the date through all the different categories. So if we take a look at donor donations by day, you can see here, this has gone across the actual console, but it's given me, for each date, it has then made the categories into columns, filled in the value where the column and date correspond, and given me NAs for the rest of them. It has recast it. So this is what I need to do to actually put it back into the visualization. So for that, I'm just going to write it into a new CSV, which you can then upload and build your viz off of, as the Guardian and the Interactives team have done. So for this, I just write what I've made there, which is donor donations by day, into a CSV and filled the NAs with blanks, with zeros, because the donation is going to be 0 for days where that category has not donated any money. So if we do that, I can then go onto the desktop and look at donor donations by day. Let me do that. And let me do that, function 11. Donor donations by day. And here, the data can be used to put into a visualization. The downfall with this, and what makes it much more difficult, is the fact that this is not done in chronological order, in that these are the dates where donations were made. It's not filling in, so I don't have a proper timeline. For that, I'm going to show you next how to do everything in just pure code in Python.